Hi, I'm glad to present our work on grid cost optimization comparing Bellman and genetic algorithms. I will start with an introduction, then I will present our microgrid model, then we will discuss the optimal management problematic, show simulation results, and end with a conclusion. The benefits and motivation behind using microgrids are many. We can cite, for example, the optimization of the energy bill, the reduction of transmission losses and greenhouse gas emissions, provide energy supply, and minimize dependence on the main grid. Hybrid system is a combination and integration of several energy sources to better use the local resources, smooth the production, reduce the amount of stored energy. It is essential to combine several sources in order to meet the needs and provide storage. The studied microgrid is grid connected. We can see in this figure that is composed of three distributed energy sources: wind turbine of 90 kilowatt peak, a gas turbine of rated power 30 kilowatt, lithium-ion battery as energy storage system of 500 kilowatt. The objective of the management algorithms are ensure uninterrupted power supply, optimize the use of renewable energy in the energy mix, minimize the energy bill and CO2 gas emissions, optimize the production on the market. The objective cost function is defined as the sum of battery, gas turbine, grid, and equivalent CO2 emission costs. In this work, the power produced by wind turbine is considered with no cost to maximize its use. To realize the energy management, it is necessary to satisfy the power balance, satisfy all operational constraints on different time horizons, determine the electricity price of sale and purchase on the main grid. It varies during the day. At each moment, the power balance should be respected. To improve battery life, the state of charge should respect the two first constraints. Also, it is advisable to use the turbine above 50% of its rated power to increase efficiency and weaken emissions. To solve our problematic, we have used two different algorithms, Bellman and genetic algorithm. The advantages of Bellman algorithm are a lot. For example, minimize the costs when the network is built, robust to find the shortest path from one node to another with high efficiency and accuracy. Simple, it does not need complicated data structures for application. Genetic algorithm mimics the natural evolution of biological systems. It was chosen because they can solve difficult problems fast in a reliable way. They can be directly interfaced with existing simulation and models. They are easy to hybridize. They have inherent parallelism which helps fast conversions. We can see here the load power and wind generated power shapes of the studied day. After simulation, we obtain these powers optimal dispatching by Bellman optimization. And in slide 16, we can see the powers optimal dispatching by genetic algorithm. We compared both results. During the studied day, GA makes an economy of 6% in production cost comparing it to Bellman. Air pollution is also reduced by 10% due to the reduced use of gas turbine. As a conclusion, we can say that the integration of auxiliary sources ensures the clipping of the power withdrawn from the main grid during peak demand. Fluctuations in wind power are balanced by the power exchanged with the main grid and the batteries. Genetic algorithms lower the production cost and CO2 emission rates for the same test day. The execution time in GA is also 4 times shorter. Thank you so much for your interest and attention.